Good morning, good afternoon, good evening, wherever you are in the world. Welcome to our talk entitled A Passive Approach to Evaluating Mridangam Transcription via Perceptual Experiment. We are from Music and Sound Cultures Research Group at NYU Abu Dhabi. Coming to the problem, the motivation is how improvisatory is improvisation in Carnatic rhythm. The questions are, what is the underlying structure behind the spontaneous variations of these rhythmic phrases? Is there any artist dependence that govern this process? Or can these be predicted from a trend, or is there any specific dependencies? And also some more deep cognitive questions on musical memory. For example, what is the form that artists memorize? And what is the schema that governs retrieval from the long-term memory that stitched a performance together? And continuing to that, there are context-dependent variations. That same sequence is treated differently in different contexts, and also memory abstractions, and if at all humans do that. Also adding knowledge constraints to the data-driven computational models to mimic the top-down ethnographic studies. And finally, the question of machine-generated music to be sounding more natural, maybe using better suprasegmental features. So just to give you a brief background on the goal of transcription, it is to create tools for beginners and lay audiences to interact with audio performance or translate to the other instruments like kanjira or khatam, and also to generate unlimited amounts of data for training machine learning algorithms via language modeling. So there has been approaches by dictionary and stroke grouping, which fails to capture long-term structure and grammar of the particular idiom, but which is successful in capturing local and short-term phrasing. So here the aim is to use syntactic as well as semantic features to closely mimic expert annotation of Mridangam performance to konakkol vocables. So our approach is as follows. It's a two-stage approach. In the first stage, to create the generic labels by roughly quantizing to manually annotate 5 frequency band levels and then timbre modeling. And in the second stage, to acoustically equivalent strokes are renamed based on the grammatical approach by n-gram modeling to have knowledge constraints. So this enables the mapping between the konakkol to Mridangam sounds according to grammatical prescriptions, which is syntactically correct. So to give you a schematic representation, it's an amalgamation of feature engineering and natural language processing to use both bottom-up and top-down approaches in a complementary fashion. So this is the broad data processing level, but we are more interested in the high-level data processing, where after getting these generic transcription labels, to finding whether they are congruent, and if not, then conduct this cognitive experiment of listen and imitate in the behavioral domain to further correct these to be more coherent with human perception and cognition. So the stimulus creation is as follows. We conduct a recording session with the performer Akshay Anantapadmanabhan, who also happens to be a co-author. So after consultation, we recorded 8 excerpts, increasingly complex phrases with konakkol, which are the vocables. And these are falling into 3 broad categories of quantized tempo of kal, jati, which is division, and the speed. And for better control in the experiment, everything is in aditala, which is an 8-bit metrical cycle in 70 BPM. And further ground truths are annotated with trained musician for understanding the likelihood of generic segmentation patterns and emphasis points. And then systematic incongruencies were inserted to violate these expectancy. So before going into the core experiment, I'd like to share the perspective on music psychology. So our questions are, what is the form that a rhythmic phrase is stored in musicians' long-term memory? What are the factors that govern that choosing certain embellishment to this canonical form or prototype, if any, of these rhythmic phrases? And in the abundance of samples available, what is the crux or nucleus of these known characteristic phrases which carries the relevant information which is pertinent to the perception and cognition? So these all ties to the schema and expectancy, which I don't need to formally introduce to this august audience. Just to briefly cover the literature on musical expectancy, there have been several authors who have noted top-down effects on musical expectancy in relation to lower perceptual processes. Categorical perception and perceptual magnet effects are 2 most prominent ones that we have referred. So the subjective approaches are various, including judging similarity on a rating scale, which is not a very likely case for a musician to correlate similarity with a number. There has been ranking with respect to a reference, which is not very likely because these incur more inter-rater agreement issues. And there are also, of course, pairwise similarity ratings, which needs further statistical modeling of projections like multidimensional scaling or t-SNE to interpret those. And in terms of objective approaches, there has been mismatch negativity, P300, 600 like ERP components, which indicates different variations of syntactic and semantic viewpoints in non-attention and attention mode of listening to rhythmic processing. I would also like to debrief the term similarity, which is very important in this paradigm. This paper by Marsden in 2012 interrogates melodic similarity. It also applies to rhythmic similarity. Is this a definitive phenomenon or the product of interpretation? And in another study, Vogt and Cranenberg argues that the similarity study or judgment is not always the acoustic similarity judgment, but it can have occurrence in a very higher semantic level, maybe categorization into tune or rhythmic phrase families. So the notion of syntax and semantics that we find most parallel in language and music is the phonology, where this transcription of syllables and phrases are like phonemes and syllables in the speech and language. So rather than segmental properties like individual transcription of syllables, the suprasegmental prosody speech feature from speech is more relevant. And that's the core feature of our experimental paradigm, which is called listen and imitate, that basically says repeat after me, which also happens to be the pedagogy in the oral and oral mode of Carnatic music. So the aim is to understand whether subjects memorize the stimulus and tend to recall from their working memory, or they simply recall a prototype template already stored in their long-term memory. To understand the following: do trained musicians perform any memory abstraction of the characteristic phrases? And are they deaf to small acoustic differences when instructed to imitate? So procedure is simple. We have 2 participant control groups consisting of 4 individuals, all male with no age restrictions. The determining factor between the groups is the experience, which is less than 4 and 4+ years. And the task is to play back the congruent as well as incongruent stimulus prompt on Mridangam with and without metronome clicks after listening as many times. And the response is recorded in quiet environment thrice in quick succession and repeated after 2 days. So we have adhered to all repetition and randomization protocols. And the judgment criteria includes these following questions: how close is the content to the original segment? Were the trains of systematic variation? Are the separate trains between the 2 control groups? Is the replacement of interpolation of incongruent or missing samples occurred by any of these experienced musicians? Does metronome has any effect on the playback, assuming that keeping to time is an additional cognitive load? And is there a short-term learning phenomenon that reflects on the renditions recorded in the repeated trial box? So I'd like to play out some sample data for the stimulus prompt randomly chosen number 5. Here you go.
Katam kitakinam dum katam kitakinam dum katam kitakinam dum katam kitakinam dum katam katam kitakinam dum katam katam kitakinam dum.
So you can see that the prosodic segmentation already chunks this whole phrase into understandable patterns, and here how the responders responded. So the first one. Let me play out another one. And another one. So we can see there are some differences of the tonic and the instrument, and we couldn't gather all the musicians together in the same studio environment given the pandemic situation. But the instructor is doing his best to evaluate with neutralizing all the other factors just to understand this listen and imitate aspect of how they have followed and how they have filled in the missing gaps. So coming to the discussion, the specific dependencies we found are that the variations can be explained via years of training, which is a proxy feature for the experience level. However, this can be ambiguous because this is self-acclaimed. And the presence of metronome indeed help maintain the expressiveness, possibly due to less cognitive load of keeping to the rhythm. And evidences of the mental schema are found, as the paradigm suggests. These results seems to be achieved in a more natural situation for the subjects because they play mridangam. And the commonly taught phrases are interpolated by experienced control group, which was hypothesized, whereas the beginners group fumbled in indecisiveness. So they didn't exactly follow. They definitely found there is something off. So the fumbleness is found. So this is the initial results that we are reporting. And reflection on the larger goal of modeling improvisation, we find that the dynamic interaction between the predictable patterns and the unpredictable gestures, which are the schema and the expressiveness, and the goodness of fit of the rhythmic expectancy is the complex dynamics of the known and the unknown incongruences found at the various temporal order of overchanging patterns. So in rhythmic modeling, we say because music is based on repetition of beats, it is said that what the next musical event will be is not always easy to guess, but when it is likely to occur can be somewhat predicted. So in search of that, we have developed computational models to find the when by some microtiming analysis, which gives reasonably good results. Then the what by some modeling techniques by timbre-modeling. But I'd like to draw your attention that these analytical approaches warrants rather cautious interpretability, because this is a simple example of similarity matrix computation, and just tweaking the distance metric changes the visualization so drastically. So we should be taking a pause before interpreting these results. And I'd like to end with this anecdote of schema versus reflex. For example, a very simple phrase, tarikete tom, was told to be mimicked, and this is how the subjects are played back. And this is how it should occur theoretically. So you can understand there is a gestural difference of the reflex because they anticipate and the co-articulation, the muscular reflex. If I play them in succession, you will appreciate the difference more precisely. So the question is, how different is different? And can machine perceive the same? It, of course, warrants an interdisciplinary study of the acoustic, psychoacoustic, neuropsychology, and musicology to find the deep cognitive problems. So the question is, can we judiciously use both data and knowledge for the task? And we do definitely advocate cognitively based AI for music. To summarize and conclude, we want to improve the current state of the camel, which is a generative model, and the current research is promising. We want to also involve ethnographic research to prove and disprove this hypothesis and then incorporate these into the computational models. And finally, the question is whether machine-generated music sounds more natural. Is this the dynamic accent, more intuitive grouping or partitioning, or a better language model? And how are acceptability and naturalness related? These are open-ended questions that we still want to answer. Here are some relevant references. We acknowledge the generous funding from NYU Abu Dhabi projects and our collaborators for their contributions. Please feel free to contact me for any further questions, and I'll be most happy to take questions. Thank you very much for your attention.